This is going to be a long one.
Boom. Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Tom Nardi, managing editor at Hackaday.
This is episode 195. No NABU for you, self-assembling 3D prints, and black hats looking at EV chargers. And this week we're going to skip the news and go straight to the action, straight to the What's That Sound challenge.
No news is good news, right?
This is a journey into sound.
What's that sound?
What's that sound?
Last week, Christina brought me a What's That Sound, and she kind of stumped me. I'll talk about that more in a little bit. Tom, you want to give it a listen?
Well, I am absolutely stumped, I will tell you for sure.
You listened to it before the show.
I actually listened to it. Come to find out, I do occasionally listen to our own podcast. So I listened to it on Friday when it came out, and I even played it back a couple times. And my vibe is like a taser or something, a very tiny taser. Like it sounds like electrical arcing, but very small and very, I think even Christina said she had to get really close to whatever it was, right? So it's not a loud and bombastic thing. Some kind of arcing electrical spark is my best guess.
I actually got brutally close to the right answer. I said, it sounds like static electricity. And then we had to cut that out because that's actually so close to being right that like when I was later like, I give up. I didn't want to mislead people. But it is the sound of static electricity when you like run your hand close to the screen of a CRT.
Oh,
and
wow.
So she had close mic'd her hand running up to a big old CRT screen and pulled the static electricity off of it.
Okay.
That's pretty good. And that's why she was talking about mic noise and quiet and all of that. It's totally legit.
Man, I had forgotten that was a thing until
Yeah.
we just started talking about it, right?
Yeah, me too.
Is she a collector of CRTs? I didn't realize she...
I think Christina's a collector of like anything old
stuff,
and
right?
ridiculous. I think she digs the old tech and has got tons of it.
Respect.
Yep.
I had a guy recently talk to me, he's like, I got all these CRTs, I think I'm just going to throw them away. And I was like, no. Like, there are people who are desperate for those things.
Yeah. Plus, I think it's probably illegal. I don't know. You can't throw CRTs away here. I know you couldn't in DC. Actually, we had to pay $10 each for disposal on CRTs at the old hackerspace. This is a liability to have CRTs. What did we got? We got 32 answers, of which 9 were stunningly correct. 9 of them actually mentioned a CRT screen. Let's see. How do we roll a 9-sided die fairly? Have you looked at these at all?
The answers?
Yeah.
No. Are there any comically wrong ones? I do enjoy those.
I'll read you those in a second. But before you look, pick a number between 1 and 9, inclusive.
7.
7 is, oh my God, Nate from Chile, from Detroit. Congratulations, Nate. Nate says, is it static on a CRT? The answer is yes. So congratulations, Nate from Chile, from Detroit. I'll get in touch with you by email and get a t-shirt coming on out to you. The rest of you listen up next week and we'll have another sound challenge. Yep. Oh yeah, you wanted some bad answers. Let's see.
Well, it's only I noticed in the comments on one of the previous podcasts, you said something like, there was 79 correct ones and 1 wrong.
And 1 wrong one.
And
yeah,
then,
I didn't.
And then the comment was like, was the wrong one so inappropriate that you couldn't read it on air? So I checked and it wasn't.
No, it was actually close. It was just wrong. No offense. Let's see. Best wrong answer this week is gonna be. Sounds exactly like when I was a kid shorting an almost empty car battery with stranded wire. The crackle of a very sad LED when too high a voltage is running through it. I don't hear my LEDs crackle very often, but
yeah, really.
We got bug zappers. You said taser. What else? Electret microphone next to a plasma ball/globe. That's pretty good. Barkhausen effect made audible by magnetizing the soft iron core of a solenoid, which is connected to an amplifier loudspeaker.
Very specific.
I think we must have run an article on that recently because that was Barkhausen's in my head too. So
that's how they know the name, right? They thought there was an in-joke or something.
Tons of people guessed static electricity, but the few who guessed CRT screen static, I had to give it to you this week.
Well, I like that several people said soldering, and I wonder how are they soldering that sparking noise sounded familiar to them. Like, oh yeah, that's the noise my soldering iron makes. Like, it's time for a new one.
Is that the bubbling of lead and rosin or something?
One person said welding, which I suppose I can see.
Yep. Tick, tick.
A little bit more than soldering. I like this one that says it must have been Christina combining her hair. I imagine it's supposed to be combing.
Autocorrect.
Combing her hair, generating
her hair.
Sparks. I mean, she could have been combining her hair, I guess. Forming into a stronger, more powerful hair. Like Voltron.
Like Voltron.
Yeah.
I'll start off this week with a nice overview article from David Johnson Davies from Technobloggy. Come learn about a new ATtiny generation. And this is really cool. He's done, for my money, the authoritative write-ups on the kind of new families of ATtiny chips that have come out since Microchip took over Atmel. If you've been playing with microcontrollers long enough, there's kind of the old school ATtinys and ATmegas, the kind that were in the old school Arduinos, and that a lot of us like played with, cut our teeth with, etc., etc. Microchip bought them up and started putting their own magic into the chips alongside. And so there are a couple new series of ATtinys now, and David Johnson Davies has done some awesome reviews and write-ups of them. Anyway, if you haven't looked into ATtinys in the last 5-6 years, they have changed dramatically. This is not the ATtiny 8s of yore. They're still 8-bit processors, but they've got a lot better / stronger peripheral sets on them, courtesy of the microchip side of things. The brand new ones have a 12-bit ADC, and it's cooler still because it's differential, which means it doesn't have to be referred to the ground reference, but you can pick another reference voltage there. You can give it a mid-rail voltage and measure like ultra small deviations around that, which is great for a whole bunch of sensors. Like I had to work with some pressure sensors that do that, for instance. They're like millivolts, but millivolts mid-rail. And that sort of thing is just hell if you have an ADC that only does full range, because you just don't have the resolution in the middle where you want it. These chips have A, differential ADC, B, it's hella fast, and C, it comes with a programmable gain amplifier, so you can measure ultra tiny voltage fluctuations. Anyway, that's not the point. The point is, well, I guess it is the point. The point is one of the outstanding features of these new series of chips is an ADC. They've got, I don't know, on the high end one, it's got 3K of RAM instead of 2K of RAM, if that's what's doing it for you. Looking through this list, I think what's stunning to me about the new series is that they're kind of priced exactly at the same price point as the old series. And that the difference as you go up and down between the ones with like 4K of flash and 32K of flash is basically insignificant. And if I were looking at these and I were a hobbyist, I think I would just go all the way for the top of the line flagship ones. That is, if you can find them in stock anywhere.
Well, it's interesting you say that because, and this is just me talking, and a good way to make a fool of yourself is to predict anything with technology, right? But I just don't see a lot of hobbyist interest in this. I feel like the ship has sailed.
Yep.
I mean, when everybody's on ESP32s and, they got multi-core processors with megabytes of RAM and Wi-Fi and Bluetooth, it's really hard for me to see, even if they are an advanced, shiny and new 8-bit MCU, it's just hard for me to see them going back. And I get why they make them, right, for industry. And of course, there's all these designs out there that, there'll be a demand for these chips for decades and decades, for the same reason they're still making 6502s. So, I get it, why they're still evolving it and making new ones, but I don't think it's for us, necessarily. Like, I would be surprised if past this post we see a lot of mention of these new generations of ATtinies on Hackaday. It's hard for me to imagine a scenario in which I would pick one of these.
Yeah.
Especially, like you said, with the pricing as it is compared to what's already on the market. And I kind of, if you look in the comments, it kind of already seems to be going in that way. People are saying, why go backwards? When we have so much power now and it's so easy. And, of course, if you have some kind of design where you need this teeny tiny chip, then sure. But if somebody asked me and said, hey, I want to get into microcontrollers, what should I get? It's hard that I would recommend even the fanciest ATtiny in 2022.
RP2040 because
Right.
it's in stock, or ESP32 because they're awesome. I mean, they've all got their own personalities, right? Like the ADC on the ESP32 is a little quirky, and the RP2040, unless you get the W one, doesn't have Wi-Fi. The W one, of course, does. Yeah, I know what you mean. And I do feel like the kind of new series ATtiny's have lost that hobbyist niche that they used to have. Like, for instance, they got rid of the reset pin. So none of the chips have a reset pin on them in the 0 series and the 1 series. That actually comes back in these brand new 2 series ones. And you think that having a dedicated reset pin isn't useful, but it's totally useful if you want to put in like a serial bootloader. So like the old versions of the 0 and 1 series of these, just you couldn't put in a serial bootloader. They changed the programming thing, so it wasn't like programmed over SPI like it used to be, but instead it uses this UPDI kind of one-wiry programming debugging thing. And so you had to come up with another programmer. And then Microchip, and this I think was a horrible mistake, made you use their, whatever it is, MPLab X and their whole system to program these chips originally. And then they were like kind of reluctantly, oh, here's a Python programmer that'll work with it, PyMCU prog. But they gimped it, or at least they didn't put any effort into making it work right. And it just uploaded so slowly that it was basically unusable. And of course, hackers took this up on themselves and fixed the situation. And actually now the official Microchip Python MCU programmer is actually fast and awesome now. But that's just because of hackers, in particular Q Bolsey and Mr. Aardvark, who did like a serial uploaders and Pi up UPDI and stuff like that. So I'll throw links in the show notes if you want to look at the history. Anyway, I do feel like the ATtiny's, like the old ATtiny's, the like old school ATtiny's, the ATtiny 85. It was so easy to just put OptiBoot on there, and with a couple diodes, you could have the thing doing USB, and all this for like a 75-cent part was really awesome and accessible, and making a programmer was dead simple. And it took kind of more hacker work to bring the new ones up to speed. The old ones worked with Arduino. The new ones also work with Arduino, but again, this is thanks to hacker work. This is Spence Conda with his Mega Tiny Core. I'll also throw links in the show notes. If you are interested in playing around with these chips and you like Arduino, this can let you do that. And it's got some extra libraries alongside that take advantage of the hardware peripherals better than the Arduino library does. So definitely go check out Mega Tiny Core for the new school ATtinys. But yeah, I do totally agree with you. And if you look through Hackaday, I guess that bears it out, right? If you look through Hackaday for ATtiny hacks, you will see people still doing projects today with ATtiny 85s. Right. And you will not see people doing hacks today with the, completely superior in every way ATtiny like 1616s or whatever, right? That just, for the same price, just dance circles around the old school ones, but they're harder to use. Oh, the new ones only come in SOIC packages. So they're, they have to be surface mount. But look, the SOIC is easy to solder. It's not a problem. Yeah. You shouldn't let that scare you. They have almost the same number of GPIOs as the Mega series ones. So they're good for that. I mean, but I hear you. I think they're not aimed at the hacker market, and I think they didn't really... They changed enough stuff that it wasn't the easiest to use thing anymore. And that's kind of what made the AVR chips standouts back in the day was that, in a day where you had to use people's tool chains, with this one you could use GCC. In a day when you had to buy tricky proprietary programmers, there was AVR dude and open source programmers you could use to run them. And I think the ATtiny may have kind of jumped the shark on that.
I still got a bunch of ATtiny 85s laying around, but I can't imagine buying the new generation.
That's a great chip, man. That was a...
Yeah, I mean, what you can pull off in
peak hardware,
8 pins is pretty cool.
Peak hardware to value, yeah.
But, I mean, there has been times where I was like, oh, yeah, I'll do this with one of the Tinys, and then at some point it becomes an ESP8266. I was like, oh, well. And I have the best of intentions. Because then you're like, oh, man, Wi-Fi would be cool.
Yep.
More pins would be cool.
Yep.
It's not like it needs to be so small. I'm not like launching on a rocket or something. And there we go.
Yep.
So I wanted to bring up this next one kind of early, since it's sort of timely and kind of an evolving situation. And in fact, I would think by the time people are listening to this, it will probably be woefully outdated. But the story here is about the NABU PC, which is something that I had no idea about. I don't know if you'd heard about previously, but this was, I guess, an attempt in Canada to give everybody a little home computer that would hook up to the cable network, if I'm understanding it correctly, and you'd be able to download stuff and chat and all the promise of the internet well before the internet was a thing for the average person. It failed, as a lot of these things did. A lot of companies tried to pull this sort of thing off back in like the early 90s and 80s. And I guess thousands of them went into some dusty warehouse, and they remained until fairly recently. And now they're kind of popping up on eBay, on these surplus sites. The article, says $60, but apparently they're coming up cheaper some places. You get a pretty cool looking Z80 machine with 64 kilobytes of RAM and, UART and a bunch of fun chips. Oh, and a really cool keyboard too. I mean, it's a pretty good deal. Only problem is when you plug it into the TV, it says, "Where is my network?" and goes back to sleep. It's like, where is my Canadian internet network through the cable line? And it goes back to sleep. The idea here, of course, is that this isn't the first time we've seen an interesting piece of hardware get abandoned on the software side, and that's never stopped hackers before. And for the price, even if you're paying this full $60, you get this like time capsule of 80s computing hardware, like ready to roll. It's never been used. It's new old stock, which is sort of rare. And immediately these things started selling out everywhere. I mean, by the time I looked at it, and I have the benefit of looking at these things before they go to print, I was already seeing them out of stock everywhere on eBay.
Oh no.
There's another company selling them as surplus, although in the comments there's some debate about whether or not you get the whole thing or just the case it came in, although it's a pretty cool case too. Like, actually, for the right price, I'd buy just the case. They have this really like industrial hardcore. It looks like something that would be on a movie set. And interestingly, I don't know if you watch the whole video, apparently it has like cap head screws holding the front panel on, but they're fake. They're literally there just for like an industrial look, which I love. So anyway, these things are going in and out of stock. People are going crazy for them, with the hope that these are going to be this like cool Z80 playground in the near future. As of like a few hours ago, I actually saw somebody has now gotten like Hello World running on them. Oh, they
cool.
They figured out where, like, what the reset vector is or whatever, and were able to inject some code. So it seems like, this isn't some far-flung fantasy. This is definitely happening in the near future. These things are going to be, usable for general purpose computing.
I had to look this up. I haven't watched the video, but I'm scoping around on Wikipedia, and NABU stands for Natural Access to Bidirectional Utilities.
I knew it stood for something, but I couldn't remember what. I'm glad you looked it up.
Ridiculous, but good for them. It's mid-80s, and so it's kind of the same time as like it's kind of like the French Minitel service in that sense. It's really interesting, and go Canada for having something kind of publicly funded and revolutionary / interesting like this. That's pretty fun. They also say it was about 950 Canadian dollars at the time, which was the same price as the Commodore 64. But then you also had to pay for $8 to $10 worth of network service on top of this.
And it is interesting how many. We should do like a roundup post or something. How many attempts there were like this to have these little internet, not even internet, like TV connected data boxes. I mean, even Nintendo tried a couple times with like upgrades for the NES, where you'd plug in like a little modem to the NES cartridge port, and it would, look at the news and the weather. And I think actually it was semi-successful in Japan. It just never caught on. But yeah, I mean, back in the day when nobody had a computer, like that was exactly. That was crazy talk. So like if the cable company was to give you this box, although quite a pricey box, I didn't realize it was that much money, and you didn't have to know anything about it, right? You hooked up to the TV, and you can see the appeal. And it's a little interesting that we've almost one of those other examples we've sort of come full circle, because now we have all the smart TVs. We've kind of gotten to where they wanted to get back then,
right?
We're now watching mind-rotting television and not learning anything.
Ironically, all we do with the TV is watch TV.
Yeah, right. I don't think anybody's checking their email on it, but you could. You definitely could check your email on your TV if you wanted to. And someone in the comments, I think maybe even the eBay seller or somebody who knows the person, said there are like thousands of them. The reason like it keeps going out of stock on eBay is just because they're overwhelmed currently.
Okay.
And they were doing it in small batches that are just getting obliterated as soon as they go up. But there are a lot of these things. It's not like there's 10 of them, and you should be fighting somebody on Black Friday morning for them. There are thousands of them, which probably would be enough to supply, the retro computing hacking scene. I mean, it's not the biggest circle, right?
Right.
So it seems like if you want one, you'll probably, maybe not today, but it seems like you'll be able to get one if you want one, which is really cool, especially if you can actually use them for other stuff. And it seems to me, not that I'm the greatest authority on this era of hardware, but it seems like you would just need to pull the ROM and put another ROM chip in it, right?
ROM, absolutely.
Because we know the hardware super well, and I don't think there's, I looked at the pictures of the board, it all looks relatively straightforward, so.
All right, well, from the past resurrected to the far future, this next one is DIY self-assembling 4D printing. Fourth dimension. This is a little bit of a hypey title, but a really neat video by Teaching Tech. The fourth dimension here is, of course, as you all know, time. And the idea is to make a 3D print in a way that it can be flattened out and then held in a flat state and then activated later on so that it folds back up into its three-dimensional self. And that's this like self-assembling 4D. The fourth dimension is time. You can think of the example that Teaching Tech, what is this guy's name? He's so good, by the way. He makes such great videos. What is his name at Teaching Tech? The example that Michael from Teaching Tech is targeting here is basically a long, thin noodle that then folds itself up into kind of a frame/box shape. And he got this idea from current research going on at MIT in particular. These all use basically joints that get activated later. So you can imagine it's printed at 90 degrees and then it's flattened out. And then something makes it want to go back to its regular state. And that would be, like Michael suggests, it could be it absorbs water and like it's made of two different materials. And so they expand in the water differentially, or like they heat differently. The method he's looking at is using PVA dissolvable filament to make kind of dissolvable locks. And so he prints something that wants to be in this one shape but is jammed by a piece of PVA. Then when he puts it in water, it folds itself up into the right shape. And that's the basic idea. But this video is actually full of lots of really interesting discoveries and tricks along the way that make it worthwhile, even if you think that this self-assembling thing is kind of a, I don't know what, goofy hoax. I don't know what it is. No, it's kind of a goofy premise. Like,
I know what you mean. Like, not goofy, but it is hard to imagine.
I mean, this is me at Hackaday saying, what's the point? But I get to say that because this is MIT working on this paper.
Because somebody mentions in the comments, like, oh, you could use this to send structures to space or whatever. Maybe the first buildings on Mars will be like this. But not if they start as giant sticks. Like, like, it'd be
it doesn't
one thing
weigh any less.
like, it'd be one thing if it was a small folded up thing that could then fold into a different shape.
Yep.
And maybe that's ultimately what they're going for. But the example we're seeing here is, like you said, a big long noodle, which is ungainly in its own way, that then forms into a structure. And it's a little hard to see practical application.
It's like IKEA flat pack furniture.
Yeah, well, yeah, I guess imagine like a flat pack IKEA furniture if every piece was next to itself and the box was 40 foot long. It's a little bit like that, like it's not convenient isn't the word exactly, but it does get the job done.
So as we were kind of suggesting that these all hinge, haha, pun intended, on having little joints that can flexibly deform and then spring back into shape. And he plays around with making the whole thing out of TPU, and then that doesn't work. It's too soft and floppy. And then he tries to make some hinges out of PLA, but they're too stiff and they end up breaking when they're bent like 90 degrees. And so he ends up with a 2-part material design where the joints are made out of flexible TPU and the kind of limbs are made out of PLA. He runs into problems with orientation of the filament, and so he has to end up printing the thing in pieces, ironically, even though it's supposed to be a one-piece thing that then self-assembles. He actually has to print it in different pieces to get the orientation on the joints right. And he puts them back together with these really clever one-way, like, arrow snappy things. It's one side is like kind of a mushroom head that then he jams into a socket and they snap together. That alone is worth watching this video, by the way, if you're into putting 3D prints together out of multiple parts. There's some really clever tricks in here for how to do that. But at the end of the day, he ends up making these kind of joints out of TPU that then want to fold back to their natural shape. And then the question is, how do you keep them in the flat shape? And he plays around with wedges. The wedges don't dissolve very well, so eventually he settles on making kind of clips or rubber band-like things that hold the joint wide open, and then these dissolvable straps are made out of PVA, and they dissolve within minutes when he throws them in water. And he completes his goal of making a stick that folds itself up into a box by the end.
There you go.
Like I said, there's so many other cool things going on here in terms of him solving these challenges that got him to this point, that even if you don't care about the self-assembling red herring, there I said it, the video is totally worth watching.
So I picked this next one. It kind of resonates with me. I suppose a little backstory is in order. My parents live on the water, and I spent a lot of my youth kind of puttering around little creeks and tributaries in my little boat. I had a gas outboard, and it's loud and nasty and leaves a slick in the water, and I always felt really bad about it. But the technology to have like electric motors on a boat just kind of weren't, well, I certainly couldn't afford them at my age anyway. So I just always had to deal with this, stupid gas motor. And I always wished I could replace it with just like a drop-in electric outboard. And now we're starting to actually see that, which is really cool. And in particular, is a conversion of an old, it just says like 70s era outboard. Right? To electric, and it was like the dream I always had as a kid, and we're starting to see it happen. So as soon as I saw this, it just made me smile, because this would have been me if I could have pulled it off and I could have had access to this sort of tech in my teen years. The interesting thing with this, it's like the total opposite of the way I would have done it, which is not to say it's right or wrong, like I'm, not the arbiter of such things, but the most straightforward conversion, right, would be to take the gas engine out of the top and just bolt, an electric motor in there and use the existing gearbox and shaft and everything. And it's certainly what I would have imagined. But in this case, Anton, who did this conversion, actually puts the motor down at the bottom. There's a case to be made for that, because right, it's you're not losing any energy in the gearing and the shafts, and you're in the water, so cooling is easier. But the big hassle is waterproofing it, and therein lies its own problem. There was a lot of cool details on this build, like Anton rewinds the motor by hand to get as much power out of it, which is pretty cool. He also uses a 3D printed propeller, which I was a little shocked by, but I suppose, in water, you're not really spinning that high of an RPM to blow apart. Like you wouldn't see, I certainly wouldn't trust like a printed fan blade in air, but in the water, there's less explosive chance, I guess. And even if it,
You
even if
won't
it
get
does
hit
explode,
by the shrapnel anyway.
right? Even if it does explode, it's under the water, right? So it's not a huge deal. So I kind of, my notes on this one, I said it was like he took every time there was an option, he was like, well, I'll do the hard one.
Yep.
And I got to give him credit for that. And the end result does look great. I mean, you would never know from the outside that it's been modified. I mean, under the waterline, yeah, it looks totally different. But externally, he's puttering around, and you'd never know, other than the fact that he's not making any noise, that this is a completely rebuilt motor.
Yeah, boy, you mentioned the hard option at every turn. He does too. Like aside from rewinding the motor, he does all of making it seaworthy himself. And so he has this like a large part of the video is about him doing the epoxy coatings and stuff to keep it from rusting. And this is in salt water, and still he says after like 10 hours there must have been some pinholes or some rubbing here or whatever, because even so there are some parts that have started to rust on the motor or on the magnets. Did you see that his boat? That's also made by himself. That's like a plywood boat that he made.
I was actually gonna say, like, when I think Dan wrote this one up, should have mentioned also the boat is made. So this guy's
yeah,
tooling around on a completely self-fabricated vehicle.
That's pretty rad.
It's very nice. I mean, I'd love to have it. But at the end of the day, I probably would have just put the motor in the top, like if I was going to do it, especially after watching this and seeing how much was involved. And in fact, we have covered something. I'll put that in the show notes. I wrote about it, I think like 2019, 2018 or something, where somebody did that. They just put the electric motor right up in the top, and you save yourself a lot of work. I mean, it might be uglier because you have this big air-cooled motor on there, but I mean, like you said, if every run you got to worry about water getting in and rusting your stuff, I mean, there's a balance there where you want to just be able to use this thing and not baby it, right?
And Anton does actually conclude that at the end. He's like, this was a totally successful project, but he's like, yeah, if I were doing this again, I would definitely put the motor above the water line so that you don't have any of these problems. I mean, the idea was sound, right? Like it's a beefy motor, and so he wants to put it underwater so it gets the water cooling automatically. But yeah. The other thing he said is that he would, if he did it underwater, he would use an in-runner motor rather than an outrunner, and that's one where this one's it's like a hobby airplane motor. The outside of it spins, the bell spins, as opposed to an in-runner where all the spinning parts are inside, and those are just easier to seal because you only have to put a seal on the output shaft, and the rest of it you don't have to worry about. Whereas this one you have to kind of dip the whole thing in epoxy and hope for the best.
And then somebody in the comments mentioned that if you put the motor up at the top, you have to add like a pump for the water and all that if you're trying to water cool it.
Yeah.
But actually, as a nerd who spent a lot of time on boats, one of the cool design things is that the impeller for the water pump is actually on the shaft, the drive shaft. So you get like a water pump at no extra charge.
Right.
When it's spinning the propeller, it's also spinning the impeller for the water pump, which is forcing water up into the motor. So you could literally just unbolt the gas motor and you would put an electric in its place and you'd still have water getting pumped up for cooling. So if you are thinking about doing a conversion like that, that's one thing you could take off your list of concerns, because you will, as long as you're spinning the propeller, you will get cool water coming up into where the motor was.
My next hack is one that I'm perennially interested in. Here's a plain C/C++ implementation of AI speech recognition, so get hacking. This has kind of been tantalizingly close for a long time. This is speech recognition on your local computer and not done hosted off in the cloud by Georgy Gerganov. And this is all sorts of awesome 7 different ways. He starts off with the smaller of the OpenAI Whisper speech recognition models. And what he does then is he kind of optimizes it to minimize memory usage. And so normally these like super big, this is a transformer model, but these super big AI models take up a lot of memory, a lot of RAM. In particular, they use a lot of GPU RAM. And that may not be something you have on your little computer, your Raspberry Pi, your cell phone. I think a Raspberry Pi might be a little bit underpowered to run one of these, but any kind of other small computer should be able to handle it. And it's basically due to him doing some really clever coding to get all the different parameters of the model minimized and in use only when it needs them. Anyway, point is, it's a few hundred megabytes download to get the smallest of the OpenAI models running on your device, and it's fast enough that it can do it locally. And he's got a bunch of different examples of this going on. He doesn't stop there. Once he has done this in C, he also then redoes it in WebAssembly. And so you can run the voice recognition in your browser as well, which is a really sweet trick. And he's got demos of it working on, I think it's people playing Counter-Strike Go or something like that. There's some video game competition and it's transcribing them in real time, and it gets some things right and some things wrong, but for completely live running on a cell phone, it's pretty darn impressive. Once you have speech recognition running in the browser, of course, the thing you'd want to do is hook this up to another AI, and he hooks it up to GPT-2 to generate things for these to say to each other. And so he's got this funny video where he's got a model doing speech recognition on one side and a model doing speech generation on the other, and the two of them are like talking to each other and having this horribly inane conversation. Like neither of them are smart. I wouldn't spend my time talking to either of them. But the fact that it's two different programs in a web browser literally having a conversation is pretty damn hilarious. I guess I completely agree with Donald Papp, who wrote this up. This is one of the first times that we've seen really good speech recognition that's doable on a simple home computer. Like, this is not, you need to spend $900 just on the GPU. This will run right now on your computer, or maybe even on a recent cell phone if you've got one kicking around.
You know, of course, the missed opportunity is we should have been running it on this little segment and putting it in the show notes to see how well it did.
Oh, well, don't rule it out yet.
I suppose we still have time.
I still have time.
It's really cool looking at it's excellent documentation too on this one. And what I thought was really cool was there's like a little example section, you know, to say like, well, here's what you could do with it, which is, I think more projects need that. Like, it's not just here I made a thing, it's here what you could do with it, including there's a thing where you could do karaoke style, you know how like the text goes on the bottom and then it highlights the current word. It does that. Like, there's actually a command line switch for making karaoke videos, which is something I never thought I'd get to say on the Hackaday podcast. But like, you let it run through, I guess, the song, it gets the lyrics, and then I don't know, I guess you do it by the tempo or something, and then it could do little highlighting things, which is like, you know, it says, oh, this is just an experimental feature, but I almost feel like that was the real goal always was. He had to pretend it was for this larger purpose just because he wanted to make karaoke videos. I also like the do you see the confidence color coding if you're doing it on the command line, which is really sweet. Like, it shows it'll show the text, and then like the color of each word shows like how confident it was, which looks really cool, you know, without having to trouble yourself with a graphical user interface or anything. It's a really cool project. I could definitely see a lot of fun things you could do with it. And had I looked into it closer, I would have had it compiled already for this application.
Damn straight. Yeah, no, the thing that looks really interesting to me is his other application where he's doing word level timestamping. So you can take something like the podcast and feed it in there. And then, you know, here's when this word was uttered. Here's where this word was uttered. And that plus a nonlinear editor makes editing the podcast a breeze, right? I'll just be like, this word, not this this word, not where I went off on the wrong track here. We'll just cut that whole sentence out. And I could do it by reading instead of by listening. It'd be super fast. So I think there's tons of interesting things to do with this technology, and it's not just making two robots talk to each other. I think there's going to be, I mean, voice recognition is really, really neat just by itself. It's worth noting in passing that what he doesn't have is a wake word detection algorithm for this yet. And so when he's doing some of his speech stuff, he presses go and it just starts listening to everything. Excuse me. He just presses go and it just starts transcribing everything it hears. So it's not quite ready yet for the, like, I'm going to make a home assistant thing. You'd want to couple that with something that could detect a wake word and then tell this one to start listening and running. But the wake word's actually the easy part. And actually last week, I think Maya wrote an article on wake words and why all of the ever-present listening devices use them. So I'll throw a link in the show notes for that. But, that's the easy part. And I think all of the hobby voice-activated home automation projects that I've seen do exactly what Alexa does. That is, they do detection of the wake word locally, and then they ship your sound file off to some servers in the cloud that then do the transcription of it. And this is doing all of that locally on your computer. This is cooler than Alexa or Siri or OK Google. And it's doing it on hardware that you probably have available to you.
Now, this next one, I was kind of on the fence. I almost even talking about it now, I'm on the fence, but I thought it was a really cool solution to a problem that a lot of people have had, and that is doing nice time-lapse animations for 3D prints. And, if you use a 3D printer, you know that the extruder is always printing, right? That's kind of its job. So it's always over the thing being printed, so you can't get a good picture normally. The trick is that you have to get the extruder to lift up, move away, park itself out of frame, then take your picture, bring it back, and start to print again, which is a hassle to orchestrate, and of course makes the print longer because you're adding that many seconds per layer, and it's, the things you have to do for internet karma, right? And the usual solution is to use Octoprint to control the printer, and I think there is a built-in time-lapse function, but there's certainly external ones that build upon that. There's I think there's a base level, and then there's other ones. Optolapse is one that comes to mind that even take it farther and give you all kind of tweakabilities and trigger in the camera, and if you have the camera plugged into the Pi, even better, because then it can do this whole dance automatically. In fact, I did a write-up a few years ago on that whole process and did a animation of the wrencher getting printed, which was pretty cool. But it's a lot of setup. You got to have a Pi or something, as we've seen recently. People are using, with Pis getting harder to get, they're using all kinds of stuff. But you got to have something hooked up to the printer, and you got to go through all this. This attempt was sort of an experiment to see if you could get away with a less cumbersome solution. And the answer is you still need to modify the G code, because you still need to move the extruder away from the printed part. But the trick with this one is that there's just a simple switch mounted to the side of the printer, and when the extruder lifts up and hits that switch, that triggers the camera on a properly positioned smartphone to grab your shot. And then when the print is done, you'll have hundreds or thousands of these still images that were taken at the precise moment with the head, extruder out of the way. And you're just left to put them together with whatever software you want to do. It's a cool solution. It doesn't require anything other than an old cell phone, and the title of the post was making 3D print time lapses with old earphones, and that's because you could take an old pair of earphones, and it's explained in the post. You send the volume up signal while the camera is open. It'll usually operate as a remote trigger. So it's pretty cool. I mean, there's still a lot of effort involved. I can't say that I'd necessarily do this over the Octoprint setup for long term. If this is something you want to do, you want to make these videos all the time. But if you you just had one animation you wanted to make for some documentation or something, you didn't want to go through the trouble of find something to put Octoprint on and all that, I could see this as working in a pinch.
Used Octolapse on mine. It's really pretty fun. You can even do like goofy things like have the head orbit the part in slow motion as you print it and stuff. It's really clever. But even back in the bad old days, a really old 3D printer of mine, the board has a MOSFET you can fire off, and Marlin has a M code in it that you can just say at every level, put this code in there. And this particular board, anyway, would then hit the gate of a MOSFET. And so you could put exactly this in there. You could, use that to trigger a camera or, a cell phone camera like this or a real camera. I think that's what it was meant to do. I never really played with it very much, but it's always cool to have like lights you can turn on and off from inside the G code and goofy things like that. There was someone implemented a power switch. I must have read this on Hackaday. We're going to have to go look this one up. Somebody implemented a power switch by putting it way at the top of the frame and having the last G-code command sent the print head all the way up and then all the way over to the right where it would actually physically flip a physical power switch and turn the machine off after printing. And that's similar in spirit to this like micro switch hack. A 3D printer is a machine. It can run around and do things for you. You might as well get it to flip switches.
Unrelated to this entirely, but like they'll add into the G code like a real long cool off period for like the bed to get cold, and then smash the extruder into the printed part to knock it off the bed and push it off to like a waiting box, and then you can run it again. Like if you don't have the belt printer, just smash into the part with your extruder. It'll be all right. It'll knock it off. Just make sure the bed's cold enough.
That's pretty good too. I like that. I'd like to start off my quick hacks this week with Tesla Coil makes sodium plasma from the Action Lab. This is kind of funny because sodium vapor lights are those kind of orangey lights that, typically are in garages or whatever. They make a lot of light for very little energy. But have you ever thought about what's going on? There's actual sodium metal in its vapor state hit by a lot of high voltage to make these things glow as a plasma. The Action Lab here does this all in the home chemistry lab with a Tesla coil, a vacuum, a propane torch, and some cut up bits of sodium metal in a glass flask. Highly dangerous, highly awesome chemistry. Love to see it happen. Next up, Glenn Akins interfacing an old engine cowl flaps indicator to USB. This is basically the classic panel meters project, but these are engine cowl flap indicators out of super old airplanes, and they just look really cool, and it's on USB. There's some interesting details in the analog circuitry to drive these. Check this out if you feel like reusing old panel indicators. Last up, Marco with his YouTube channel MVV, which is apparently loved by every Italian in the audience. I've got 2 turntables and a laser engraver. He's taking a laser engraver and cutting the lines into a record. He does it with some old code from Amanda Gazai. He has to modify it to convert it to 45 RPM and adds RIAA pre-emphasis. If you don't know how records work, there's actually a really nice explanation in here. Ends up making laser cut records of his own voice out of wood. And then he says he's doing it out of vinyl. I and everyone else in the comments hope he's doing it out of acrylic because laser cutting vinyl is dangerous, dangerous, dangerous. Extra bonus, I'll throw the link to Amanda Gazai's laser cutting your own wooden records from Hackaday back in 2015 into the show notes.
All right, my first quick hack comes from the 8-bit guy. This one is Portable Commodore 64 Lives. I thought this one was cool on one hand because I had never seen one of these luggable Commodores, and apparently they're relatively rare. They didn't sell very well. And also because it's just, a classic kind of repair story, which I always like to see on Hackaday. It's, changing chips one at a time until you get a change in what wasn't working, and then you work from there. So it was just a really cool success story and a look at a rare piece of vintage hardware. Next up is Blackout Logger, keeps track of power outages. And this one's cool for a number of reasons. It's a little e-ink panel that has kind of a running log of when the power goes out. And it's a little, I read this several times, and it's somewhat mysterious to me how this works, but it seems like there's a real-time clock. It marks when the time starts, and then, it goes for like 30 seconds or whatever, and then puts a log, entry in the log file that like period closed. And if there's a period where it didn't make either the close signal, it assumes the power went out during that time. It's a little bit vague, and you might say, well, why is the power going out so frequently that every 30 seconds it needs to be checked? And it comes out that our creator is in Ukraine and is recording just, the day in the life in an active war zone. And it's kind of inspiring to me that this kind of hacking is still going on with everything that's happening over there. And you gotta give respect for, everything's going on. And you're like, I know what I'll do. I'll spend my time working on some blackout monitoring gadget for my desk. And last up is Telnet gets stubborn Sony camera under control. I cheated and I wrote this one myself, but I really liked it, so I wanted to bring it back up. This came our way from Ven Stone, who is technical producer at Linux Gamecast, and he really likes the Sony A5000 camera, which, despite coming from 2014, is still a pretty competent HD video shooter. He's using the HDMI output into a capture device instead of recording it on the camera for, reasons that we don't have to get into here. But the HDMI output has this stupid overlay that shows, like the battery level and stuff that is not helping him when he's trying to make a podcast or whatever. And there's no way to turn it off. But coming to find out, there is a reverse engineering effort for many of these Sony cameras, and among the functions that it has is it can turn on like these developer options that include running a Telnet server on the camera. And from there, you can Telnet into the camera, which runs some kind of Linux or Android. I actually couldn't figure it out from the documentation, but a Linux kernel at the very least. And you get a little BusyBox environment, and you can manipulate the actual bytes in like the configuration file, and that will let you turn this overlay off. It's a really cool story because, you can get this cheap camera, you can turn off this annoying feature, and it's a competent, video device. And I also thought it was really cool that there's this whole Sony reverse engineering package that I believe we hadn't seen until this point. So if you're looking for a affordable, hackable camera, this might be something to keep an eye on.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And this week I'm going to pick EV Chargers Could Be a Serious Target for Hackers by Lewin Day. And here, of course, he means the black hat hackers, because EV chargers they're like a trifecta. They combine aspects of the ATM, that is, you could put skimmers on them because people have to put their credit cards in. They're all internet connected, and so they're a little bit like print servers or have the same kind of vulnerability surface because they're often configurable by Wi-Fi locally so that the people in the gas station can, do their maintenance or whatever. And worst of all, they talk to your car and to the power grid. So there's this whole like heavy-duty power station / infrastructure side to them, and you combine these three different attack surfaces together in a relatively new product, electric vehicle chargers, and not a surprise that it's a serious target for hackers, is it? And so Lewin goes to mention a couple of these and also a research paper by Sandia National Labs, which you should totally check out. I think what's striking to me is that when you look through these, especially the Sandia paper and this other hack that he links in here called Broken Wire, a lot of the details of how exactly they work are still being kept secret because they are probably out there in infrastructure right now and a real problem. And it's really funny because, for instance, this Broken Wire attack is a software-defined radio-based attack, and they're using, I think it was a Lime SDR or something, not anything inaccessible to you or I, to jam cars' charging sessions remotely over wireless. And the reason they're able to do this at all is that the cars communicate to the EV chargers and negotiate how much power they want to get sent across. And they're constantly feeding back to say, hey, my battery isn't on fire yet. Keep giving me more power. And apparently you can jam this signal, which then, again, details are scarce, I'm guessing here. What they do is they jam the signal, and then that prevents the charger from giving the car more power. If you read in the comments here, some people who sound like they know something about this, there's a lot of back and forth between the charger and the car when it's getting charged, especially with the like super fast charging modes. There's a lot more handshaking and negotiation of how much juice to send across than you might naively expect. And in that sense, it's a little bit like, it made me think anyway, of USB power delivery, which has also got this kind of device and power supplier negotiation going on all the time. Except this is then, kind of the big grown-up infrastructure version of the same thing. It's interesting. It's kind of the Wild West. It's kind of this new frontier, and it's kind of time for, I think, security researchers to start looking at these things and poking them and see where they fall down and get them fixed up now before the bad guys start looking at it.
Oh, I'm sure they are. Somebody's got a charger they pulled off eBay in their basement right now, and they're poking at it furiously.
Yeah, right?
I like the end of this one is, says, thankfully, Sandia National Laboratory has provided a document on best practices for the EV chargers. And it turns out the best practices for EV chargers are the same for everything. It says, physically secure it, make sure everything's updated, put the web interface behind a firewall. I mean, it the same thing you should be doing with your home router. So I guess it's a reminder that the simplest things are often the most effective. Just if you can keep people away from the thing, there's a good chance they won't be able to fiddle with it too much.
Yeah, but you say simplest things. You have to imagine these are people running gas stations who are being charged now with this like cybersecurity infrastructure. Like, this is not an easy problem. This is
no offense to any gas attendants that may be listening to the Hackaday podcast.
This is like putting my father-in-law in front of a computational astronomy project, he's out of his depth,
Well, I mean, that is a good point, though. How does that work? I don't know the answer. Like, is the gas station really responsible for it? Or is it like a third party that comes in and says, hey, we're going to put these things here. Don't touch them because you're gas attendants. Don't touch these. You're going to break something.
There's no way this should be on the shoulders of the person running the gas station, right?
Right. I would hope not. all due respect to the gas station attendants. This does seem like a little bit outside of their job description. But yeah, I would imagine they're just like you rent space from the gas station, which incidentally, I guess we can't call them that in coming decades. Rent space from the propellant reloading area, and you operate them remotely, I would imagine. But yeah, if you can operate them remotely, then potentially somebody else can, so that's another problem.
I think by their nature, they have to be internet connected. Like you say, the admin stuff shouldn't be available to everybody, but like they need to be on the network because they need to do payments processing. They need to be on the network because they need to, God knows what they need to do with power load balancing and stuff. Right. I think it's a non-trivial problem, and I do think that it's something that, we'll see being an interesting story. Kind of the way ATM machines, I just said it, kind of the way ATMs were 20 years ago. I think this is going to be that kind of a big public infrastructure that people need to poke at for a while before all the bugs get shaked out.
Other than the ridiculously high voltages coming out of it, this isn't fundamentally different from, the ATMs or even gas pumps. I mean, right? If you have a gas pump people are putting their cards into, you could just as easily have a skimmer on there. Yeah. So, I mean, some of this stuff isn't a new challenge necessarily. Gas pumps might be internet connected these days too. I honestly don't know. I mean, it wouldn't surprise me if they were at least connected to the network in the building and doing some kind of remote telemetry.
I wonder how they update their prices, because they update prices all the time.
Yeah, they do.
I wonder if that's done with wires. That's what I'd do. But I wonder if these days some of them are wireless.
Yeah, I'm sure. Like it'd be crazy if somebody had to go out there and like punch it in to each pump, right? So there must be
Right?
some central management system.
Yeah.
Like the article starts, computers are in everything these days. Like
Yeah.
they really are. So it'd be interesting. If anybody wants to send us their inside knowledge about fuel pumps, please feel free.
Get me a radio and go sniff around the local
There you
gas
go.
station, see what I can see.
My can't miss comes from Al Williams, and this is another one of his where he just sits you down by the fireside and tells you how things used to be, which I really love because nobody waxes nostalgic like Al Williams. This one is How to Repair the Death of Schematics. He says, he starts up saying, like, back in the day, in my day, anybody with a soldering iron could start a repair business, basically, because you always had the back panel, you always had the schematics, and the stuff wasn't that complicated in the grand scheme of things to begin with, and a TV was so expensive that it wasn't unreasonable to pay somebody to come out and look at it. And I remember that even from, this isn't, I don't want to put too much of a number on Al, but this is an ancient history. I remember when I was a kid, my dad would have the repair guy come and he'd be fiddling in the back of the TV like a lot.
Yeah.
And it was some monstrous like projection that he got from a spa or something. So it was like it had higher than normal value, and I guess it was worth it. But like I feel like every couple months this guy would come and he'd calibrate the projectors and he'd do something. And there's actually a very formative moment in my young life. Is the guy, he was trying to fix the TV and he said, "Oh, something's wrong. Something's burned out." And he asked my father, he's like, "Does your son have any like electronic toys that he wouldn't miss?" And he gave him this little remote-controlled car that I'm sure I was very upset about at the time. And I remember him taking it apart and staring very knowingly at the PCB, taking it apart out, putting it in the TV and making it work. And at the time, I thought this is literal magic. Like this is a wizard had come into our living room. And now I realize he probably pulled like a resistor out of the board, because it had burned out. And the adult me wonders, like, well, why didn't you bring resistors with you, guy? You knew you were coming to fix the TV. But, like, at the time, I was so amazed that this dude could look at a remote-controlled car, pull something out of it, and use it to fix a TV. It seemed like, how is this possible? And
Yeah.
I could say, you could say it probably put me on a certain path, right? So, it's totally legit that this was a thing. Like, you used to call somebody, and he would come to the house, and he'd fix your TV because you couldn't just go to the Best Buy and buy one for $100. And that's where we're at now. You can go get a big screen TV for like $100. And yeah, it's probably going to be telling somebody what you're watching. It's going to have some built-in spyware or whatever, but $100 is $100, right? So he kind of just goes on to talk about this bygone era of repairability and the idea that like when you bought an appliance, it was just like, of course you're gonna get schematics. Why wouldn't you get schematics? And it's something that has just gone away, right? We don't even think about it now. Like when's the last time? Maybe like in a dryer or something like that, but certainly most of our consumer electronics are like on the verge of disposable. There's no documentation that comes with them. There's no schematics, and even if there was a schematic for your phone, what are you gonna do with it? All these microscopic parts and a thing that's glued together, you couldn't fix it anyway. More practically, Al does talk about like some of the services that were available where like you would send away for these manuals and schematics in case the thing didn't come with it, because you had these repair shops that needed information, and it was like a whole big business was selling this kind of stuff. And he sort of makes a comparison to like the unofficial car repair manuals that you could still find. You go to like a auto repair place and they'll usually have a book for your car, or at least a few years give or take your car that has all the information and stuff in it. And he talked about like the parts availability and where you could get stuff. First of all, there's a lot fewer parts in a TV from this era, so that wasn't so hard. So it's just kind of an interesting trip down a memory lane that not all of us even have the memory of anymore, because now it's just, the TV's broken, I'll get another one. The phone's a year old, I guess I'll get a new phone. Part of me would like to see this kind of thing come back, but I think the ship is too far gone. I think, unfortunately, repairability for most of our stuff is beyond the point. Even if you could get like a schematic or a book from the store, it's just, who's going to do it? When the things are so cheap. My TV had stopped working for a while, and I was like, I'll just get another one. I finally felt so bad because it would keep turning off. I took it apart, and it was like literally a loose ground wire. and that was it. But I was very near just to buy a new one.
Right.
Just because it was so cheap, and part of you is like, oh well, if I get a new one, it's gonna have better resolution, it's got better color, because it literally the stuff is improving by leaps and bounds every year. So it's almost like, why even repair the old stuff when it's moving so quickly?
No, what I really love about this article is some of the schematics that he includes here and the repair guide pictures and stuff, because that's actually stuff you could use today. Like there's this one really neat photo of it's a photo of a PCB and it's got a grid superposed over it. So you can say, not just capacitor number C123,
that's nice.
but like the big electrolytic at M23, and you're like, oh yeah, well there it is. You sunk my battleship. And then there's another schematic where it's got nominal waveforms, and it's got a line, and it's like, if you tap it here, this is what you should see on your scope. It's like the sweep generator in a TV or something. That's really awesome too. And that level of documentation is absolutely something we should be striving for. I know I worked on fixing a radio transmitter. It was a piece of professional broadcast gear, and I had no idea what I was doing. But the schematics and instruction, and I guess it was like halfway between schematics and a repair manual for this thing, had all these test points, and it's like, test here, and if you get 3 volts, it's good. If you get no volts, this is something, this transistor is probably busted. And that was actually really helpful for us. At the end of the day, of course, the transistor that was busted was the one with all the black soot around the board on it, and it was visibly obvious what was wrong. But we actually got to that part by tracing the voltages and following along in the instruction manual, which was really super cool. Some of this kind of practice of documentation that's, long gone is nonetheless kind of inspirational to us, or should be inspirational to us today.
He talks about this company, Sam's Photo Facts, that would send these documents, like you said, with the grid, which is really wild, like being able to see that grid. And it's like that was their bread and butter, was like sending out this information to independent repair places. And it kind of reminded me that I found that recently there's a similar service that mechanics use, and they have a DIY branch. And if you go on there, and I actually just signed up for it, so it's kind of cool. you put your what your car is. So the DIY version is you can only do one car, right? Like a mechanic would have access to all the cars,
right?
But it costs crazy. If you sign up for just one car, it's like $60 for the year, and it has all the information on your vehicle and all the wiring diagrams and all the stuff. And I actually got it not long ago and was pretty impressed. Like, the services are still out there, I guess. Not for TVs. I mean, like, it has to be something worth repairing. Like, so there still is like these centralized repositories of knowledge, but the you must be this high to ride is a lot higher than it was back in the day.
Well, that about wraps it up for this week's Hackaday podcast. Thank you very much for listening. If you want to comment on this episode or follow any of the links, head on over to hackaday.com/podcast. If you see anything cool or do anything cool, write us at the tips line, tips@hackaday.com. And until next week,
keep on hacking.
Hello and welcome. One more time.
Good to get the mistakes out early, right?
Shake it out.
And I'm Tom Nardi, managing editor. Someone's screaming in the background. Yeah, now this dog's barking. I'm sure the third time's a charm.